Hi guys, in this series of videos we'll start by learning about capacitors, and then we'll look at how we charge a capacitor at a constant current, then we'll look at capacitance, then we'll look at the energy stored in a capacitor, and we'll finish with an exam style question.
So let's start by looking at capacitors. So what is a capacitor? Well, a capacitor is just an electrical component that stores charge, and this is the circuit symbol for capacitors below, and we'll be seeing that in the circuits we encounter. So this is how we represent a capacitor. And actually that's a very helpful way of drawing it, because really often a capacitor just takes the form of two parallel metal plates, and we've seen those kind of things already. Remember that those were a good example of a uniform field. So really, when we saw this in a previous video, what we've got here with this charged plate, equal and opposite charge on both sides of these plates and this electric field between them, this is an example of something like a capacitor. This is a very basic kind of capacitor. But obviously, actually capacitors are incredibly prevalent. You'll find them in just about every single device. They're very, very useful, and so there's actually a wide variety of designs and many different versions. And we'll see kind of a more sophisticated look at how to make a capacitor a bit later. But also there are just plenty of others which are kind of beyond the scope of what we're going to look at. But it's helpful to look at this and just think, parallel metal plates that can kind of really see that simply through the circuit diagram. Circuit symbol for it here, just these two parallel lines here representing potentially metal plates, if that helps you to remember it. So how does a capacitor work? Well, it's just a circuit component, and when we connect it in circuit with a cell, current flows in the circuit, because remember, you need to have a complete circuit for current to flow. And if you look at this circuit here, we've got our cell here with, say, a potential difference across it of, say, epsilon, and so we're going to current flowing in our circuit. Just our charge will be flowing like this. But we'll have an issue here when we hit this metal plate, right? Because there's the circuit isn't complete. We've got a gap. We've really just kind of got this gap across this plates, and there's no way for charge to get from here to here. What actually happens is that charge is stored on this plate and removed from this plate to carry on completing the circuit. And that way we get a current flowing in our circuit. We'll call that current I. But what's actually happening is that it's not that a charge here is going all the way around the circuit. What's happening is a charge is going here, being stored on this plate, and then it's removed from this plate and carries on going back to the cell. So the way current flows in the circuit is by removing charge from one plate and depositing it on another, on the other plate. So we remove charge from this plate and deposit it on this plate. So what that's going to do is going to build up an equal and opposite charge on each plate. So that's why I was saying earlier, this example here of our uniform field, this is an example of a capacitor because we have this equal and opposite charge. That's kind of how a capacitor works. You have these two parallel metal plates.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.